Bismillahirrahmanirrahim. My name is Mohammad QUSYAIRI bin ROSLI, and my matrix number is B0922110017, and I will present about ultrasonic testing. So the first is I want to talk about the fundamental and the theory. Ultrasonic testing is a powerful non-destructive testing, is NDT in short term, that use high frequency sound wave to detect, defect and inspect material. It is widely used in the various industry, from aerospace to construction, to ensure the safety and the quality of the construction or the structure and the component of the machinery. Next is I would like to talk about basic principle of ultrasonic testing. So ultrasonic testing is a typical inspection system that consists of several functional units such as pulsar, receiver, transducer and display device. A pulsar or act like a receiver is an electronic device that can produce high voltage electric pulse. Driven by the pulsar, the transducer generates high frequency ultrasonic energy. The sound energy is introduced and propagated through the material in the form of wave. When there is a discontinuity in the wave path, part of the energy will be reflected. The reflected wave signal is transformed into electrical signal by the transducer and is displayed on the screen. In the applet below, the reflected signal strength is displayed versus time from the signal generation when the echo was received. Signal travel time can be directly related to the distance that the signal travel. From the signal, information about the reflector location, size, orientation and other features can sometimes be gained. Next, I would like to talk about the advantage of ultrasonic testing. So ultrasonic testing is sensitive to both surface and subsurface discontinuities. The depth of the penetration for the flow detection or measurement is superior to other NDT method. Only single site access is needed when the pulse echo technique is used. It's highly accurate in determining the reflector positioning and estimating its size and shape. Minimal part preparation. It provides instantaneously result, detailed image, and it is non-hazardous. It is non-hazardous to operates or nearby personnel, does not affect by the material being tested, and it other use such as thickness measurement. In addition to flow detection, its equipment can highly be portable and highly automated. And next, the disadvantage of ultrasonic testing is the surface must be accessible to transmit ultrasound. Linear defect oriented parallel to the sound beam may go undetected. Materials that are rough, irregular shape, very small, exceptionally thin or homogeneous are difficult to inspect. Skill and training is more intensive than with other method. It normally require coupling medium to promote the transfer of sound energy into the test specimen. Cast iron and other coarse grained material are difficult to inspect due to low sound transmission and high signal noise. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Mohammad SHAMIN bin SAMSUDIN. My matrix number is B0922101142. I will continue for our group presentation about ultrasonic testing. I would like to explain about scientific formula in ultrasonic testing. Generally, we have 8 main formula for ultrasonic testing. Firstly, longitudinal wave velocity, which is VL equal to square root E bracket 1 minus V divided by rho bracket 1 plus V and 1 minus 2V, where VL for longitudinal wave velocity, E for modulus of elasticity, rho for density, and V for Poisson ratio. For the next formula is shear wave velocity. Vs equal to square root E divided by 2 rho bracket 1 plus V, where Vs for shear wave velocity, E for modulus of elasticity, rho for density, V for Poisson ratio, and G for shear ratio. For the third formula is wavelength, which is lambda equal to V divided by F. Lambda for wavelength, V for velocity, and F for frequency. For the next formula is refraction or Snell law, which is sin theta 1 divided by sin theta 2 equal to V1 divided by V2, where theta 1 for angle of the incident wave, theta 2 for angle of the reflected wave, V1 for velocity of incident wave, and V2 for velocity of reflected wave. And then acoustic independent, Z equal to rho V, where Z for acoustic independent, rho for density, and V for velocity. Next, reflection, R equal to Z2 minus Z1 divided by Z2 plus Z1 bracket power of 2, where for R energy reflection coefficient, Z1 for acoustic independent of medium 1, and Z2 is acoustic independent of medium 2. For the second last formula is near field, N equal to D square divided by 4 lambda, N for near field, D for transducer diameter, and lambda for wavelength. For the last formula is beam spread of angle, which is sin theta equal to 1.2 lambda divided by D. Lambda for wavelength, D for transducer diameter. Next, I will explain about equipment operation. We have 5 equipment operation for ultrasonic testing. Firstly, ultrasonic transducer to convert electrical energy into sound wave and vice versa. Secondly, pulse or receiver, generate high voltage electrical pulse that are sent to the transducer. Next, display unit to present the result of the ultrasonic inspection. Next, couplant, a medium used to facilitate the transmission of ultrasonic wave from the transducer to the test material. And the last equipment is calibration block, to standardize block used to calibrate the equipment and ensure accurate measurement before use.
Name is WYNER William, matrix number B0922100042, and now I'll be presenting about the procedures for ultrasonic testing equipment. First of all, there is the equipment setup. So the preparation of equipment, that is the ultrasonic testing instrument, and also including the required PPE needed to be worn. Next is the surface preparation, just to clean the surface of the material before the testing is done. And then couplant application, where the couplant usually a gel kind of medium is used to help the traveling of sound waves into the material. And then the probe placement, where the probe is placed on any area that is needed to be tested on the surface material. And then sound wave emission and echo reception, where the signals are then shown into the display screen of the instrument, but calibration is still needed to be done, which is why calibration is performed by referring to the standards that are already given, and the parameters are then adjusted to get an accurate data analysis. Once all of that is done, the data is then recorded and is documented for interpretation and evaluation by the inspector, and then the inspector with all the results would be reporting the results to be decided on what follow-up actions are needed to be done. Next is defect detection. So generally reflected sound waves that are shown as signals on the ultrasonic testing equipment analyzed to be identified as potential defects. So a material that is flawless would usually show sound waves that travels and reflects evenly, but when defects are detected, you can see the sound waves are disrupted, that causes it to reflect prematurely or even show an additional echo before the backwall echo. So the characteristics of such signal reflections can range from height, shape, travel time, and as well as movement when displayed on screen. So this will enable inspectors who are performing the ultrasonic testing to indicate the potential presence of a defect. So here are a few examples of defect detection. When a crack is detected, you can see there's an additional echo that shows a small crack for the reflection of the back surface echo. And then materials that have a gap, which is porosity, it shows a flaw before the back surface echo, which also shortens the signal of the back surface echo, meaning the flaw is doesn't show as uniform of a signal as the material should be. And that is all from me.
Assalamualaikum. My name is Amir Hazmi bin Mohammad Hanapiah, and I will present about the innovation and improvement of ultrasonic testing. So we got 3 advanced ultrasonic testing which have advanced function compared to conventional ultrasonic testing. So firstly, we have a phase area ultrasonic testing, which is, we call it PAUT. PAUT utilize multiply small transducer element that can be electronically controlled to create complex beam pattern. This allow for detailed imaging and inspection of complex geometries and critical component, making it particularly useful in aerospace and advanced material inspection. Phase area ultrasonic testing can be used to inspect large surface area quickly with high resolution. And then PAUT can typically be conducted more quickly than conventional ultrasonic testing. Then after that, PAUT is able to create a detailed and accurate cross-section of an exact tree by increasing the probability of detecting anomalies. Secondly, we have a robotic ultrasonic testing. Robotic ultrasonic testing systems are being developed to perform inspection more efficiently and consistently. This system can handle complex geometries and repetitive tasks, reducing the need for manual intervention and increasing inspection speed and accuracy. Robotic ultrasonic testing provides advanced ultrasonic visualized in 3D environment and overlaid in CAD and fast inspection speed. After that, robotic ultrasonic testing flexible and adaptable robot cell which can quickly be modified to inspect new part. And then lastly, robotic ultrasonic testing can inspect complex geometry part. And then third, time of flight diffraction, TOFD. TOFD, time of flight diffraction, is one of the most reliable non-destructive testing method in testing well for both pre-service and in service inspection. There is no radiation with this method. Time of flight diffraction provide inspection data in recorded can be stored digitally for future reference. After that, time of flight diffraction can inspect result immediately and quickly inspection. Time of flight diffraction is sensitivity to all flaws type including crack, slack and lack of fusion. And then lastly, able to create accurate sizing of defect. After that, I will present about the case study. The case study that related with the ultrasonic testing is the ultrasonic testing in pipeline inspection. The explanation is a major oil and gas company needed to ensure the integrity of its extensive network of pipeline. This pipeline, which transport crude oil across vast distance, are critical infrastructure. The problem is pipelines are subject to various forms of degradation, such as corrosion, cracking, and material loss due to the harsh environment they operate in. Traditional inspection methods were either too invasive or could not provide the detailed information needed to assess the pipeline condition accurately. So the solution is the ultrasonic testing was employed because of its ability to detect and quantify internal flaws with high precision. The method involves sending high frequency sound wave into the material and analyze the reflected signal to identify any anomalies. That's all.